Hello everybody and welcome to Pre-Calculus Online at Frederick Community College with Professor Lockman. In this video, I will go through the logistics of taking your first major assessment, Exam 1, and I will go through a brief review of the topics that we need to feel comfortable with in order to complete this major assignment. So as you know, there is already a folder open on Blackboard for Test 1 information. If you go to Unit 1 on the left panel and then go to Week 5, you will see this information that gives you just basic details about this test. Per syllabus, each test is 25% of your overall grade. 15% of that is the electronic portion, which is administered through Newton Alta. Okay, and if you click on this link below, you will see the basic information for Test 1. Okay, so it starts on Monday, February 22nd, and you have a week to work on it. It contains 40 questions. The time limit is 3 hours. You will not necessarily need all of that time. The problems on this portion of the test will be very similar to your homework assignment. Okay, in fact, they will be identical, maybe slightly different numbers here and there, but they all come from the assignments that you guys have been working on this whole time. Okay, you have 2 attempts. If you are not satisfied with your first attempt, you may take it again, but you don't have to. Let's say you get a really great score and you're happy with it, you do not need to take the second attempt. Having said that, once you take your first attempt, you will be able to see which questions you got incorrectly. Okay, my recommendation is to review those questions, and if you're not sure why your answer is wrong, please reach out to me. Okay, I will be able to look at your work, at your answers, and we can discuss it so your next attempt you won't make the same mistakes. Okay, so that portion is auto-graded just like your homework assignments, exactly the same problems, maybe slightly different numbers. Okay, so once that's finished, the other portion of the test is written solutions. I strongly believe mathematics needs to be learned by doing problems by hand, and we should be able to write well-composed solutions using correct notation and terminology. So this is part of the test that will not be auto-graded, but rather I will be collecting your work and grade it by hand, just like I would collect papers in a standard traditional class, right? Okay, so this portion of the test is 10% of your overall grade. You will have 1 attempt. However, there is no time limit to it. Once you have access to it on Monday, you can take all the time to work on it, and you may use your notes that you've been taking over the class. You may not use anyone else's help. Okay, so this should be your work. Okay, all right, and then you will be able to submit it right here, where right now it says Test 1, Part 2. This portion will be available on Monday, February 22nd. You will be able to access a PDF file, and you can write on it, you can print it out and write your solutions, and you can type whichever your preferred method is, and you'll be able to submit it through Blackboard. Okay, so now that you know the logistics of the test, let me go ahead and give you a quick review, and this will also give you an idea of what your paper test will look like. Okay, so your paper test portion will be similar to what I'm about to go through, but not necessarily the same. Now, all of these problems come from your activities or worksheets that are not collected for grading, right? So those supplementary worksheets that I upload for students that prefer to work by hand. But here, I'm giving you a chance to take a look at what a full solution looks like. Okay, so let's go ahead and go through these problems. Now, these solutions will also be uploaded on Blackboard for you guys to review. So I'm not going to be going through every single step. I'm just going to focus on major components of each problem. Okay, let's go ahead and do that. So the first problem is asking you to solve the equation. For this type of problem, I expect you to show me all the steps, not just the answer, okay? So some problems will be a little bit more involved. Here I only have about 3 steps. I open the parentheses, combine like terms, give you the final answer, okay? So that's a simple linear equation in one variable. Then the next thing we need to know how to do is solving rational equations, okay? I combine my 2 fractions on the left. We get to have the same denominator, which means the numerators are the same, right? So I'm writing out all the steps, not just the answer. The final answer is -1. Some of you might be tempted to check your work by plugging in that back into the original equation. That is completely fine. It's a very good strategy to check if you done your work correctly. Okay, so rational equations, yes, this is one of the topics that we've covered in Module 1. Definitely know how to solve this type of problem. Complex numbers. Here's a problem that's asking me to divide 2 complex numbers. How do we approach this problem? I need to multiply the top and the bottom by the conjugate of what's in the denominator, right? So that's the first step that I need to show. Then I do all the arithmetic, simplify my answer. The answer is -I. Okay. Next problem is solving quadratic equations using the quadratic formula. So here I'm specifically asking you to use this method. Okay. You do not need to write the formula, but just to give you a reminder what that looks like, there it is on the left. Okay. Now I apply the formula, showing all the steps. I come up with my answer. X is equal to -3 and -5. Okay. Now, of course, you see this equation is fairly easy. You could have solved it by factoring, right? But again, I want to emphasize the instructions say use the quadratic formula. Okay. The next problem is a radical equation. Okay. So we have 2 radicals, one on the right, one on the left. We can square them. Okay. We get a negative number, and in this case we get negative number under the radical. So assuming that our answers can be complex numbers, this is completely fine unless it says otherwise, right? So you can check that you get a root of -3 on the left and on the right. So this is the solution. Okay. Next topic was absolute value inequalities. Okay. So here I have an inequality going to the left, right? Absolute value of 3x plus 5 is less than or equal to 1. So how do we solve an inequality of this type? I have my algebraic steps on the left. I have a graphical representation of what that solution looks like, and it's a closed interval. Another type of problem is when the inequality is going the opposite way, okay? So how do we handle this compound inequality, all right? So here, when we drop the absolute value, okay, we have 2 options. We have 2x minus 3 is less than -2 once we do some simplification, or 2x minus 3 is greater than +2, okay? And that gives us a union of 2 intervals, right? Okay, so there are 2 types of absolute value inequalities that we should be able to solve. And then this is a simple inequality, problem 7, where we need to write the answer using the interval notation. I'm also giving you a graphical representation of what this interval looks like, and emphasizing that, okay, whenever we have these parentheses, that means we're not including the endpoints. So on the graph, that means what? These endpoints will be hollow dots. Okay. For problem 7b, you see that we have inequalities less than or equal to or greater than or equal to, which means the endpoints will be included. Okay, we use square brackets for those. And if you were to make a graphical representation of the solution to this inequality, the endpoints would be solid dots. Okay, so those little details are definitely important, and we need to make sure that we use correct notation and correct representation of our answers. Okay, let's take a look. We're moving to the section where we talk about functions. So here's the problem that's asking us to determine whether a function is one-to-one. Okay, one way to solve this problem is give a brief sketch. Okay, just a rough sketch of function. So I have a linear function and I have a cubic function. Both of them are one-to-one because they pass the horizontal line test. Okay, as I make horizontal lines, they all cross each of those functions in exactly one spot. All right. Okay, domain and range. So domain for this particular relation is the collection of points that are first coordinates, right? Okay, so I have 2, 4, 5, 8, and 11. I put them in order. You don't necessarily need to order them. Okay, that's just a habit. And the same goes for range. These are second coordinates of all of those points. Again, I prefer to put them in order, but it's not necessarily needed. Okay. Let's see, now we're going into graphing of basic functions. So here I have f of x is equal to 2 absolute value of x plus 4. So I need to graph a function that's absolute value, but it's modified, right? So we have movement, horizontal movement, 4 units to the left. And also that 2 in front of the absolute value, that's what's producing the vertical stretch. Okay, if you would like, you can check a couple of points. So here I said, okay, what if x is equal to 0? What do I get for that? Oh, no, I didn't use 0. Sorry, I used -4. Okay, so you can see that I plotted points for x is equal to -4, -3, -2, and then there is symmetry. Okay, so this is enough work. If you want to show the actual points that you graphed, that's fine as well. But this would be full solution to a problem like that. Okay, and another one where we have a parabola, x squared plus 3. It's a parabola that opens up and it's shifted 3 units up. So not much else to show here. If you want to add a couple of points that you plugged in, that's fine. But really, there's not much else that we can provide here as far as supporting work goes. Okay, domains of functions. Okay, so here I have 3 functions. A linear function whose domain is all real numbers. So the interval notation for this is from -infinity to infinity. I have a rational function where we want to exclude numbers that make denominators 0, right? So in this case, it's -8, +10. And then I have a radical function. Given that we're dealing with real numbers, we do not want negative numbers under the radical. So x minus 3 is greater than or equal to 0. That means my domain is from 3, including that 3, to +infinity. Okay. Let's see. Next question is asking us to graph a piecewise defined function. Okay. So we have this split of the domain to the left of 1 and to the right of 1. The function looks different, right? So it's a quadratic to the left of 1, not including 1. Otherwise, it's not a function. Okay, and then it's a line with the slope 2, starting at x is equal to 1. So you can see that for my linear part, the dot, that point 1, 3, it's a solid dot. However, for the quadratic part, because its x is less than 1, strict inequality, that dot, which is that point, which is 1, negative 1/2, that is not included in the graph. Okay, otherwise, the vertical line test would tell us that this is not a function, right? Okay, so this is one little subtle detail that we have to be careful with whenever we graph piecewise defined functions. Okay, moving on. Here, I am giving you an example of what supported work looks like for computing the difference quotient. Okay, and this is something that you guys will be doing a lot once you get to Calculus 1. So this is pre-calculus, right? So we're preparing you for some big concepts that we will be discovering in our next math class. All right, so you see all the steps. I usually compute the numerator first, simplified, and then it's easy to divide by the denominator, okay, which is just h. So your final answer here is nice. It's 2x minus 5 plus h. And in your next class, you will actually be able to understand what this expression means, okay? Find the average rate of change for the function. Okay, the formula here is f of b minus f of a divided by b minus a. What is my b? My b is 6, my a is 3. I evaluate my function at 6. I evaluate my function at 3. Subtract those two and divide by the difference, right? Again, right now we're looking at this expression, just trying to get comfortable computing it. But in next class, we'll make this connection of what is it that we're really trying to find here, okay? So all of this will come back to you guys in Calculus 1. All right, let's take a look at the next problem here. A graph is given to me and I'm asked to find the local minimum and the points where that happens, okay? So the local minimum here is -1, that's the value of the function, and that happens at x is equal to plus or minus 3. You can see that this function is symmetric about the y-axis. So I indicated both on the graph and also just written what the value is and where this minimum occurs. Okay. Next problem is asking us to find these combination of functions. Pretty straightforward. You have two functions. What is their sum? What's their difference? What's their product? Okay, so here I'm showing you all the steps that's needed to get full credit. Not much to do. You add two functions, simplify, combine like terms. Same goes for part B. We would do the subtraction. Part C is the product. Okay, that's function combinations. Now we're into function composition. I'm asked to evaluate f of g of 1. So with these problems, we'll work from the inside out, right? So first I find g of 1 just by plugging 1 into 4x in the function g. Okay, I get 2. Then f of g of 1 is f of 2. Again, simple evaluation gives me a nice number. 8 is the answer. Okay. Determine whether the following functions are even, odd, or neither. Okay, so here I'm asking you to do this algebraically by definition. So we plug in -x and see what happens to our expression. You can see for 19a, you get negative of f of x. By definition, this is an odd function. And you can also check this by sketching it. Okay, you can use Desmos to graph this real quick and see that you have symmetry across the origin. Okay, the second part, I evaluate my function of -x. I get exactly the same thing as I started with. That means our function is even. Okay, even functions are symmetric about the y-axis. You can graph this real quick and see that you get a parabola-looking function that is symmetric about the y-axis. Okay, so whether it's algebraically or by sketching, one way or the other, you can check your work. The next problem is asking us to do function transformation. So a graph of function is given to us, so think about it as your parent function, as what you start with. And then I need to graph y, which is negative 2 times f of x plus 3. So I'm writing out all the transformations that happened. I have vertical shift 3 units up, right? Then I have reflection through the horizontal axis and the vertical stretch, okay? So the order of how you write these things doesn't really matter, as long as the picture is correct, right? So you can think about it as you flipped it first, stretched it by 2, and then also shifted 3, or the other way around. It doesn't matter, okay? But then you come up with the graph, and it looks like it's been flipped, right? It's stretched 2 units, and I also have vertical shift 3 units up, okay? Let's see, next few problems, I think these are the last two. Determine whether these two functions are inverses of each other. How do we do that? We compose functions and see if we get identity. Okay, I composed f with g, I get x, and also g with f, I also get x. So these two functions are indeed inverses of each other. Okay, and then the last problem is asking us to find the inverse of the function. F of x is a rational function to x minus 3. How do we do that? We set up y is equal to the expression, then we interchange x and y, and we try to solve this equation now for y. So here I'm showing you all of the steps on how this is done. Then once I isolate y as a function of x, that is my inverse. Okay, so this problem could be a little bit involved, right? You see there's a lot of steps here. So carefully go through this solution. Let me know if you have any questions. Okay. Right, that's everything. So this is a brief review, right? You've done a lot more problems over the last 4 weeks, okay? Your homework problems are a little bit more involved, but this is as much as you're going to need to know for the paper portion of your test. Again, I want to say that your problem is not necessarily going to be these exact problems. They will be similar, okay? Similar problems, slightly different numbers, okay? Maybe slightly different order, right? So right now, this review sheet looks like I've done problems in exactly the same order as we learned the material, and I usually stick with that, okay? But yeah, so this is what I wanted you guys to see, what it's expected for full credit for problems that are done by hand. Okay, all right, I'm gonna go ahead and stop right here. So if you have any questions at all, I will be available to meet with you online or just communicate through email, but please do not hesitate to reach out to me for help or just any questions that you might have before you take this major assessment. All right, thank you for watching.